Okay, chapter 5.2, perimeter and area of similar figures. So first let's look at perimeter. If two figures are similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. So the perimeter of, let's call this one A, and B will be equal. So the perimeter of A over perimeter of B would be equal to this side over this side. So we'll say 4 over 6. And if we simplify that, 4 over 6 simplifies to 2/3. So that would work. Now I wonder what it looks like if we actually kind of add some numbers and see where we go. So this is 4, say this is 6. And so if we use our similar rectangles thing from last section, we'd say that 4 over 6 is equal to 6 over, we don't know what this is, we'll call it x. And 6 times 6 is 36. And 4 times x, I shouldn't use this x because it's confusing when we start getting into algebra. 6 times 6 is 36, and 4 times x is also 36. X has to be 9. So we're going to put 9 in for over here. So we used a little algebra there to find out how to make these two rectangles similar. And then we're going to go ahead and we can find the perimeter. Perimeter is always P, is 4 plus 6 plus another 4 plus another 6. Or you can do 4 times 2 plus 6 times 2. Or you can do 4 plus 6, which is 10, and multiply that by 2. Either way, you add up all the sides around there and you get 20. And if you add up all the sides around here, 6 plus 9 is 18. So we have another 6 over here and another 9 over here. 18. 6 plus 9 is 15. Sorry, plus another 15 is equal to 30. So this perimeter is equal to 30. And so the perimeter of 20 over 30 is definitely equal to the same as the 4/6, which is the same as 2/3. These are all equal. So we can see that it's true. And it's nice to be able to use that. So we can just use one side and use the corresponding side to find the perimeter ratio. So that's what we're looking for, finding ratios of the perimeter. Finding the ratio, this is important, of perimeters. Okay, so we just have to have one and then we can find the other. Now we're going to find the area of similar figures, and the important part here is the squaring. Area always has to do with squares, but let's read this. If two figures are similar, then the ratio of their areas is equal to the square of the ratio of their corresponding side lengths. So this kind of sounds like gibberish, but we're finding the ratio of an area compared to the sides. So we're doing basically the same thing that we already did, but now we're, instead of finding perimeter, we're finding area. Alright, so say we have a triangle, and we have a similar triangle, and these may not look exactly similar. We're just going to have to assume that they are. This has a side length of 6, and on the corresponding side we have 10. Now remember, if we wanted to actually find the area of the triangle, we'd have to use a formula that includes a height. And we can't really do that for this because I don't know the length of the base or the height. We only have the side. So we might have to do this and then check it with something else. But we're going to use the same idea. The area, see, we're going to say, we'll call this A and this one B again. The area of A over the area of B is equal to the square of the ratio of their corresponding sides. So we're going to say, well, that's equal to the square of the ratio. So we have the ratio written down as 6 over 10, A over B, 6 over 10, but we're going to square it. And that's going to look like 36, because 6 to the second power is 36 over 100, because 10 to the second power is 100. Now, it could be that we might have wanted to simplify that first. 6/10 is the same as 3/5. And if we square that, we get 9/25. And this looks simpler. Of course, we could simplify this too by dividing by 4 and dividing by 4, and we would still get 9/25. It might have been easier to simplify ahead of time, which is what we did here. So the ratio of the areas is 9 over 25. Now this isn't as easy to prove as we did with our rectangle, so maybe we ought to try one. Let's take a square and a bigger square. And so if we, maybe I'll change colors just for fun. Say this one is 3 and this one is 5. So the area of this one, length times width, is 9. Area equals 9 squared. Okay? 9, not 9 squared, 9 units squared, like your inches or centimeters. And 5 times 5 is 25 units to the second power. Let's see if I can write that a little nicer. Okay, so we have the same thing, but we're going to use our areas, which is area A. We ended up being 9 over 25. And we're going to see if it's the same as taking our sides, which is 3 over 5, and squaring them. Does that make sense? Because it's the square of the ratio of corresponding side lengths. So we're finding our corresponding side lengths and squaring them, or taking them to the second power. Well, 3 squared is 9, and 5 squared is 25, and that's a very simple. We can see that's true. Okay, so that's nice how that works, and you can just use that real-life application wherever you want. Say we have a photo album. Photo album has a cover that looks like this. You place a picture on the page of a photo album. The page and the picture are similar rectangles. So this is like your page, and then this is like your picture. They're similar. How many times greater is the area of the page than the area of the picture? Well, they're telling us maybe this one is 6 inches and this one is 8 inches. So the picture is 8 inches, but the page that you're putting it on, sorry, the picture is 6 inches on the bottom, the width, but the book has pages that are 8 inches. How many times greater is the area of the page than the area of the picture? Well, you're going to find that ratio, the area of the page over the area of picture is the same as the length, or the width. It says length in the book, but as the width of page over the width of book. Not book, picture. It's important to remember that if I have page up here, then I keep page up here, and if I have picture down here, I keep picture down here. So the width of the page, I almost forgot to square it. Okay, so the width of the page was 8 inches over the width of the picture, which was 6 inches. Notice I've got the large one on top this time. It doesn't matter as long as I keep it going. Now I'm going to simplify first. 8/6 is the same as 4/3, and then I'm going to square it and get 16/9. And it's 16/9 bigger. So it's more than once, but not quite twice as big in area. That's all there is to it. Now, it might ask you, the area of the picture is 45 square inches, so we could say that this area is 45. What is the area of the page? Well, since we know the ratio, we can now figure out the area of the page, which is bigger. The area of the picture is 45. So we put the area of the picture here. Remember, it's on the bottom, and we'll just keep it there. Area of the page, we don't know. We'll call it P. And then it's going to be equal to 16 over 9, because that's our ratio. And this is when it starts to become valuable. And you end up doing cross products to figure this out. So you have to do 45 times 16, and that's going to equal 9 times P, and you end up dividing by 9 to get P by itself. So it's 45 times 16 divided by 9. To solve for this one, you multiply these two and then divide by 9. It's almost like you go in this direction to find out what P is. 45 times 16 divided by 9 to our handy calculator. 45. Come on. 45 times 16 is 720 divided by 9 is 80. So the area of the page is 80 inches squared. That would be the second question you could answer. Now you can look at your book. That's going to walk you through the same thing. I might have confused you because this is sort of advanced usage of algebra and math and ratios. It's all really cool, and I'm glad that you're getting a chance to experience it.